Okay, then at this point we're ready to go ahead with our analysis. And f of pi, so we plug in sine of pi is equal to 0, and 2 plus 0 is 0, so we get ln of 2 for the first answer. For sine of 3 pi over 2, sine of 3 pi over 2 is negative 1, and so 2 plus negative 1 gives us a positive 1, and natural log of 1 is 0. At 2 pi, sine of 2 pi is 0, 2 plus 0 is 2, and natural log of 2 gives us natural log of 2. Now again, we're not asked for the coordinates here, we are only asked for the absolute maximum value and the absolute minimum value of the function. And the absolute maximum value is natural log of 2, the absolute minimum value is 0. And that completes part A. Find the x-coordinate of each point of inflection on the graph of f and justify your answer. Alright, so we're looking for the point of inflection, so we're going to have to find the second derivative. And for this I'm going to use cosine x over 2 plus sine x as my starting point. And so I have low d high, the derivative of cosine is negative sine, minus high d low, and the derivative of the denominator is just the derivative of sine x, which is cosine x, divided by 2 times the denominator. Sorry, the denominator squared. Now when I multiply out my numerator, I'm going to get negative 2 sine x minus sine square of x minus cosine square of x, all divided by 2 plus the quantity 2 plus sine x, quantity squared. Now fortunately in the numerator, if I factored out a negative 1 from negative sine square x minus cosine x, I'd get negative 2 sine x minus 1 times sine square x plus cosine square x, which we know is just 1, over 2 plus sine x quantity squared. So this now gives me negative 2 sine x minus 1 over 2 plus sine x quantity squared, and we're looking for where that's equal to 0, and it will equal 0 whenever the numerator is 0, and that is when 2 sine x equals negative 1. I had negative 2 sine x minus 1 equals 0, so I move the negative 2 sine x to the other side, and I get 2 sine x equals negative 1, or when sine x is equal to negative 1/2, and there are 2 places where the sine will equal negative 1/2. Those are the 2 places just below pi and just below 0, which are 7 pi over 6 and 11 pi over 6, one in the 3rd quadrant and one in the 4th quadrant, and they happen to both lie within our x greater than or equal to pi and less than or equal to 2 pi original interval. This is still not enough. We still do need to test these values. So I'm going to move the problem up just a little bit, and we still do need to have a sign chart. Since we're working with a closed interval, I put the endpoints of pi and 2 pi. Now, what you should note is that on the unit circle, as theta sweeps down from pi to 7 pi over 6, the sign of that value will be to the right of negative 1/2. Now let me just step back for a second. What is it that we're looking for? We're testing the second derivative. We want to find points of inflection, so we need to find where the second derivative changes sign. We know that it becomes 0 at 7 pi over 6 and 11 pi over 6. So we're going to test on either side of those zeros. And I'm going to use this negative 2 sine x minus 1 over 2 plus sine x quantity squared as my second derivative for the test. Since on the interval pi to 7 pi over 6, the sign will be to the right of negative 1/2. So we could use negative 1/4 for sine of x there. Negative 2 times negative 1/4 is positive 1/2, minus 1 is still negative, over a positive is negative. We'll pick up in the next video.